Okay, so where's all this at? Okay, that eye that's right behind you, that one right there, bring that one over too. Not that one, yeah. Let's bring that one over. Thanks. Because this has some stuff that the other ones doesn't. I'm just going to go down the list here, you guys, and then you should have enough time as soon as I finish this to go back to your benches and look at it a little closer. Okay. So we pulled these eyes apart. Let me pull this one apart here. Okay. So again, be careful with taking these apart. We're missing things like the lenses. You can see they're really getting beat up pretty bad. This goes with this one. This one goes here. Okay. So starting at the top, B, fibrous tunica. That's the outer part, you guys. That is your sclera. Okay.
The white part.
And you can see it there, the white of your eye, the sclera. Okay. And it forms the cornea. The cornea is this clear thing right here. Okay. That's your cornea. So if you went to poke right towards, try and go in your eye, that's what you would hit would be your cornea. Okay. So cornea and sclera make up the fibrous tunica of the eye. Okay, we okay with that one? Okay. The next layer in is going to be your vascular tunica, and it consists of the choroid, which on this one you can see the sclera white. See that little red between the orange and the white? That's your choroid right there. You can kind of see it right there. See that red in between the white and the orange? That's your choroid. You can, on this model here, sclera, this would be the choroid right here. You actually can see it as red, but it's this layer here, okay? And then what we're going to see, the retina is on the inside. Now, the other part, what happens is you'll see that choroid, as you come towards the front of the eye, the anterior part, it widens out into this area right here, okay? So that whole widened area there is called your ciliary body. Your ciliary body. And if you look in there, it looks like there's little muscles in there. And that's what's in there, is ciliary muscles are in there. Okay? So this area right here. On this model, it would be this area right here. Ciliary body. Okay? And on this eyeball here, the darker red is the choroid, and here's your ciliary body. That black is part of it also. Okay, right there. So that's all ciliary body. And again, the muscles in there are the ciliary muscles. Now, the lens is held in place, you guys, by suspensory ligaments. This is your lens right here. Okay? You can see on this model. Here it is here on this model, the lens. It's not on that model. It's gone. Okay? And it's held by what's called suspensory ligaments. And on the models, it's these little white lines here. See all those little white lines? Okay. You can see them there. You can see them here too. See those little white lines? Suspensory ligaments. They attach the lens, and that's what holds the lens in place. On this thing, you don't see the white lines, but there's little lines in there you can see. Right. Those would be the suspensory ligaments. They're just not colored. You know what I mean? So those little lines that are in there going like that would be a suspensory ligament. Okay, so that was the fibrous and vascular tunica. Nervous tunica, that's your retina. That's where you have all your photoreceptors and stuff, okay? And so on the inside line of all these, this is all retina. So this is orange here. I don't know what color is that. You know? This stuff here with the blood vessels, that's all retina, okay? Within the retina, some of these things you can see on some models better than others. You see listed on the retina there, fovea centralis, macula lutea, optic disc, and ora serrata. Okay, so first, see this little yellow disc, half disc right there? Okay, that's your macula lutea. That's where you guys are focusing your light right now. And if you look real close, it's hard to see, but there's like a little dimple in the very middle of it. Can you see that little dimple? Mm-hmm. See that little dimple in there? It's like a little dimple right in the middle of that yellow disc. Mm-hmm. Okay? That's your fovea centralis, that little dimple. It actually, the retina is thinner there, okay? You don't have that bipolar layer on top of it, and the ganglion layers off to the side. And you only have cones there. This is what you're using right now in your eye. You're focusing just down on that little dot right now. And that's where the cones are for color and bright light. Okay? And most of that macula of lutea is also cones. When you get out further, you're going to see rods. That's for when light goes down and it gets dark and you want to see, you start using the rods. Okay? So, fovea centralis macula lutea, you can see it on this one. There's like a little number 13 or something here with a little pinkish looking disc there. Okay? That would be your macula lutea right there. And I think on this side of it,
I don't see it.
yeah, on this one here, see this little pink disc right here? You'll notice there's like a little dot in the middle of it. Okay? See, it's got that little pink disc and there's a little dot in the middle of it. So the disc is the macula lutea. The little dot in the middle of it is the fovea centralis. And again, that's what you're using right now. Okay? Is that fovea centralis. Okay, so there we are. Ora serrata. See this dark stuff in that little jagged line, like a saw, like a serration? Ora serrata. That line, that little jagged line. They're not so jaggedy here, but it'd be that little jagged line there, okay? Ora serrata. Okay? We okay with that part of it?
Yeah.
Okay. Conjunctiva. It's what's going to be the blood vessels that are covering the sclera, and you don't see it good there, but where you do see it is, where's that little eyeball? Oh, here it is here. See that, those blood vessels? That's your conjunctiva, your bulbar conjunctiva, okay? Palpable conjunctiva, that's on the underside lid. Remember that kid in 4th grade that would lift his little eyelids up? And did you do that?
Of course not.
And so here it is here. It's this stuff here under the eyelid. That's the palpable conjunctiva. Bulbar conjunctiva, that's when you get a red eye, you know, your eyes are red. I don't know if you didn't sleep or whatever. That's what's getting, looks red, is those blood vessels. Cavities. You've got an anterior posterior cavity. The cavities, you guys, are divided by the lens. Now remember, this is the lens here, okay? And you put it in. This thing in front of it is your iris. The hole through the iris is what?
Pupil.
Your pupil. And so that's what can get bigger or smaller. So the pupil isn't something you can touch, it's a hole, okay? So, the cavities. The lens, everything posterior to it is in the posterior cavity. So my Q-tip is in the posterior cavity.
Posterior.
Okay, posterior cavity. Anterior to the lens, between there and this cornea, is the anterior cavity. So my Q-tip is in the anterior cavity now. Okay, anterior cavity. Now, the fluid, which this plastic ball represents in the posterior cavity, is like a jelly. It's real viscous, and you'll see it when we do the eye dissection. It's called vitreous humor, or you also see it called the vitreous body. So this here represents the vitreous humor.
Like viscosity.
That's what this represents right here, vitreous humor.
The whole inside is like jelly-like, or just
Yeah.
like a layer?
In the posterior cavity, the whole thing's full, but that represents it, okay? This whole thing, this ball here, would be the vitreous humor, okay? Right there. The anterior cavity, remember that's anterior to the lens? That's going to have fluid in it, and you'll see, but it's more like water, and it's actually called aqueous humor, because it just flows like water, whereas this is like jello, you know, okay? Now, here's the kicker. The anterior cavity is further divided into 2 chambers, an anterior chamber and a posterior chamber, and the division is the iris. So between the cornea and the iris, my Q-tip is in the anterior chamber of the anterior cavity. Between the iris and the lens, where my Q-tip is now, posterior chamber of the anterior cavity. Now, The posterior cavity doesn't have an anterior posterior chamber. Only the anterior cavity has an anterior chamber, posterior chamber. So don't confuse the two. Okay, we okay with that?
Why is the posterior
And
on
so
the side?
on the testing, you guys, you got to watch the wording. Am I asking you for a chamber or am I asking you for a cavity? I would never ask you for a chamber in the posterior cavity because there's no chambers in the posterior cavity. There's a posterior cavity, posterior chamber in the anterior cavity, and there's an anterior chamber in the anterior cavity. Okay, we've got that straight?
Mhm.
So you can see it here on this model here too. Okay. This represents the iris, this thing right here, and the lens is here. So my Q-tip is in what space? If I ask you what
Posterior
space?
cavity.
Posterior cavity, right. And then up here, what chamber am I in?
The anterior chamber.
Anterior chamber, anterior cavity. Good, you guys got it. You got it nailed. Okay. Oh, I did skip one thing up on the retina, and that was the optic disc. I'm sorry, I skipped that. I didn't mean to. I just now realized I didn't talk about it.
What's funny?
So remember this. What was this this yellow little disc right here? Back of the lutea and the little dimple in the middle. Fovea centralis. And
centralis.
when do you use that? For
To focus
color,
light.
yeah, for color, so all the cones are right there. So
Cones.
remember, we looked up there. You saw that you're going to activate those rods and cones, which then activate the bipolar layer, which then activate the ganglion cells. The axons from all the ganglion cells in your retina exit right here at your optic disc to form your optic nerve. And so this little thing right here with the blood vessels in it is your optic disc. You have no receptors there. And so that's your blind spot. And in your book, there's a little thing you can look at that shows you how to find your blind spot. Okay? And so that's the optic disc right there. You can see it right here on this one, optic disc. This one here doesn't really show it because it's this hole where this is the optic nerve coming out right here. Okay? That's when the doctor looks in your eyes with an ophthalmoscope, that's what he's focusing on because it won't hurt you, Now, what he'll do is he'll tell you to look straight, and for a second he comes over and looks right at your macula. That's when that bright light comes in and kind of blinds you for a second. You can't shine that light on there very long. But when he's shining on that optic disc, you don't really, you feel the light, but it's not that intense. Mm-hmm. And what he's looking at are those blood vessels coming out. Because the blood vessels, the central artery and central vein come through here, and you can see the blood vessels going through the retina. This is the only place in the body you can view blood vessels. And so eye doctor, an ophthalmologist can diagnose a lot of other things systemically in your body, like diabetes, he can tell, stuff like that, that you have by looking at those blood vessels. If you have atherosclerosis, he can see it in those sometimes, Okay, so we're okay with the cavities. I showed you the lens, right? The iris and the pupil, we okay with those? Okay. Optic nerve, again, optic nerve here, optic nerve here, optic nerve here coming out. So here's your optic nerve, okay. Accessory eye structures, upper and lower palpebral, the eyelids. The only place you really see these on any of the models would be this right here, okay. And then the carbuncle on there, the carbuncle. That's that little thing that's right, that little bump that's in the corner of your eye here. And so see that little pink thing right there? That would be your carbuncle. That's where that stuff gets stuck there, in the morning when you wake up.
Ew.
That's not what people call it, the tear duct.
Some people call it that, but it's not. Yeah. But it's not. Carbuncle. Yeah. Lacrimal apparatus. Okay, you've got a lacrimal gland that makes tears. They're going to collect through the nasal punctum into the lacrimal sac and then empty into the nasal cavity through the nasal lacrimal duct. Now, you don't see any of that on this model, okay? And so where you see it the best is over here on this model.
Professor,
Yeah.
what did you just say?
Did I say it wrong?
No,
You
it's
know,
just
you
a
none of
lot,
us
really
understand what you just
fast,
said.
and a lot.
It was so fast, like I don't get it.
Right here, you got your lab manual with you?
I'm sharing it
Sure.
with you.
Okay, lacrimal apparatus right there.
Okay,
Lacrimal gland's going to make the tears. It's going to collect in the lacrimal punctum and drain through the lacrimal sac into the nasal lacrimal duct.
okay.
Got it?
Crossword puzzle.
What I'm actually doing here is just trying to get you to see the stuff first. Okay, so on all these models, you can see this. Remember, on this model, this muscle sits like this. There's your lacrimal gland right there, making the tears. On this model here it is right here, lacrimal gland. On this model here, they show it out here, lacrimal gland. So the lacrimal gland sits up here in the eye, makes the tears come across your cornea like that. Okay. And then now they're going to collect in the corner of your eye here into the lacrimal sac, which is this bulge right here. And in the middle of it, you see that little hole right there?
Right.
That's the lacrimal punctum. Now there's actually more to this. There's these canals and stuff like this, but and I'll show you a little bit there, but they're not on your word list. So that's the lacrimal punctum in the middle of the lacrimal sac. And now you can see my Q-tip down here shows where it's draining. You're going to drain into your nose, in your nasal cavity. And so that is your nasal lacrimal duct. It's going, okay? Nasal lacrimal duct. Okay. This one kind of shows the lacrimal sac. That would be the nasal lacrimal duct here. It really does. The punctum would be right where this connects right here. Okay. So these are actually canals carrying tears. That's how you're getting the tears in there. Okay. Okay. So this model here doesn't show. It only shows the lacrimal gland. Okay. Okay. Questions? I know I went through that real quick, but I want to give you time to go look at it. Yeah.
My
Quite a
question's
bit.
kind of curiosity. What would benefit of epicanthic fold? Like, why have more races, certain races have more pronounced folds?
I have no idea.
Dog syndrome.
And I'm not sure, and you know what, I just never looked into that, but there must be some people that have a reasoning behind that, you know, why one race developed that versus other races did.
It's
You
really
know.
Tears only start from the medial side of the eye?
No, they're released up here,
Well, that's what they call
but they collect down here.
it's like symptom when you have
What's up with those movies where they start on the outside?
It's fake.
Epicanthic fold is.
They squeeze them
That's
out.
how you know they're not good actors.
Yeah, how it's safe.
that's
Well, you mean they're
Yeah, I
crying
know.
tears
People
out?
with Alzheimer's syndrome, their eyes
just
kind
'cause
of, it kind of goes over
Yeah, that's
that.
just-
Like mine's a
this.
bit more pronounced than yours.
Like
Yeah,
when
some
you
people,
have
some
you know
people
what I mean?
have it, but when you
But like,
would cry.
like obviously.
That-